Hello. All right, so we've got one more topic that we have to cover on exponential functions. We did the graphing, we did the solving, we did the word problems, and we did rate of change yesterday. Now we have to write the equation of the function. So I've got a couple problems to go through with you so you can kind of see how it flows. It's actually not that hard at all. I think you'll find this quite simple. All right, it's all about finding the pattern in the output. All right, so you're going to focus on that Y list to see what the pattern is, because you'll notice in the X list, it's very boring. The X list just counts 0, 1, 2, 3. 1, 2, 3, 4. -1, 0, 1, 2. So the X list just is going in order, whereas the Y list shows what the actual growth is. Okay, so before we get into it, right here is the generalized form of exponential functions, where the exponent is the variable. Then you've got the A, which is the initial value, right? This is your y-intercept. And then the base, that is the growth or decay rate, right? It's the growth or decay rate. All right, so when we look at this first example over here, the y-intercept, okay, so here's the y-axis. The y-intercept is a point on the y-axis. That means that the x value here, right, all of these points going along here, here, all of these values have a 0 for x. Okay, so to find this y-intercept, we have to find where x is 0. In the chart, boom, there it is. So this is our initial value. This is going to be my A. All right. So now we have to look at the rate. Looks like these numbers are getting bigger, so it's growing. So it has to be a number greater than 1. Let's see, going from 2 to 4, looks like we're doubling. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So all of these are times 2, times 2, times 2. So our base, our base is going by 2. So our equation can now come together. We've got the function. You can also write that y equals if you want. This is that fancy function notation we learned back in February. Anywho, our function will be 2, and then the base 2, and then the variable is the exponent. Ta-da! And you can always check yourself if you have these fancy calculators. If you wanted to go to the table and edit this function in here, you have 2 times 2 to the x. And then you just compare the chart on the paper to the chart on your calculator, make sure it matches up, and sure enough, looking good. All right, let's try number 2. All right, so number 2, we want to find that initial value, that y-intercept, when the x is 0. As I scan through it, oh man, they didn't give it to me. So I'm going to have to do a little bit of legwork. No big deal here, because 4, 3, 2, 1, the next number would be 0. So I just have to think about what this pattern is and go back one step to get this initial value, right, that y-intercept. Okay, so pattern time. 1, 3, 9, 27. I think I see it. How about you? If you multiply by 3, multiply by 3, multiply by 3, right? That's how you're getting these values. So that is the pattern. We're multiplying by 3. Okay, so if we have to go back a step, what must this have been that would have given us a 1? Maybe you know it. Maybe you need some algebra to help you get there. Okay, so going forwards, we multiply. What's the opposite of multiply by 3? Divide by 3. Yeah, so if we want to go backwards, we would divide by 3. So 1 divided by 3 is 1/3. All right, if you want to check yourself, right, check it out. You've got 1/3 times 3, right, because that's what we're saying the rate is. So if this is 1/3 and we multiply by 3, we should be getting this 1 out. And we do. All right, so 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. All right. So now we've got the 2 pieces that we need. We can write our equation. 1/3 times 3 to the x. So you've got your initial value in the front. You've got the base, right, that rate. And then the variable is your exponent. I'm going to leave number 3 for later. Let's check out number 4. All right, number 4, yay, they give us the y-intercept. So our initial value is 5. Now we just need to find the pattern. 1/5 to 1. Sometimes it's not so easy at fractions. Maybe skip over the fraction and look at the other numbers. 1 to 5, 5 to 25. It looks like we are timesing by 5, right? 1 times 5, boom. 5 times 5, boom. 1/5 times 5 is indeed 1. So our base is going by 5. So our equation is f of x equals the initial value times the base to the power x. Check out number 5. Okay, so my initial value, that y-intercept, is not in the chart. So I have to do a little bit of work to backtrack to the 0. All right, so let's find this pattern. Going from 2 to 8, 2 times 4 is 8. So let's see if this works. 1/2 times 4 is 1/2 times 4, 2. Let's check it. All right, 1/2 times 4. It is indeed 2. So I'm thinking times 4 times 4. So if I need to go back in time, what's the opposite of timesing? Dividing. So we can we can divide 1/8 by 4. So we have 1/8 divided by 4. So the next one back here must have been 1/32. And even if you didn't have a calculator, maybe you would have seen this. Because look at those denominators. 2 times 4 is 8. 8 times 4 is 32. All right, so we've got that 4 involved here. Okay, so our initial value is this weird fraction, 1/32. The base is changing. It's growing at a rate of 4 times 4 times 4 times 4 times 4. So your equation would be 1/32 times 4 to the x. All right, take a look at number 7. We've got, no y-intercept. So we have to think a little bit. Let's see, we're going this way now. -4, -3, -2, -1. What comes next? 0. And that's what we need to get our initial value, that y-intercept. Okay, so 240 to 120 to 60. I'm thinking divide by 2, right? If I divide by 2, divide by 2, divide by 2, divide by 2. All right, but our base is going to be in terms of multiplication. So instead of saying divide by 2, we need to turn it into terms of multiplication. So we're multiplying or we're cutting in half, right? Multiply by a half, multiply by a half, multiply by a half, right? Cut in half. So our rate this time is getting cut in half, all right? Because you can't put it in as divide 2, right? You have to put it in as a fancy fraction. All right, so our initial value then, what is 30 divided by 2? What is 30 cut in half? That would be 15. So our equation would be f of x equals 15 times 1/2 to the x. All right, let me do one more with you. We've got 1, 2, 3, 4. All right, so we have to find the y-intercept ourselves. Let's see what this pattern is. 27 to 81. I'm thinking I multiply by 3. Let's see, 27 times 3. Yep, let me keep going. What's 81 times 3? Yep, okay, so it looks like we are multiplying by 3 on these, right? Times 3, times 3, times 3. So my base is 3. All right, so if we go back in time, what's 27 divided by 3? That would be a 9, right? 9 times 3 is 27. Looks good. So our initial value, our y-intercept, is 9. Our equation is f of x equals 9 times 3 to the x. All right. Well, in the words of the East Side Boys, I'm going to leave you 3, 6, 9. They're fine. Do you know that song? Maybe you're too young. All right. Have a good day. I can't stop it.